Okay, so today we'll discuss about YAML kind of manifest files, how the syntax and what are the uh, like uh, parameters we have. All those we'll discuss for the different Kubernetes resources. First starts with the namespace. Okay, so now here we are going to create a namespace. Okay, in the like a command line also using kubectl like create namespace. That namespace name we can use, but in the Git or DevOps wise, what is the best practice is always manage them through the manifest files or maybe through code itself. Better to create instead of GUI or command line. And all these we can keep in which location? In the source code itself. That's the reason it's not a best practice to create them through CLI or graphically. It's better to create them through YAML itself. Okay. So then the same here, this YAML code, what we have given. Okay. So now here, if I created a YAML. Okay. So then I'm going to give the name as like maybe namespace dot YML I can give or YAML I can give. In this, if I keep this one, then kubectl, I can use create hyphen f. That YAML file is namespace dot YAML I can specify, or YAML I can specify. Or second time onwards, if I do any changes, then I can use apply hyphen f. For the first time, I can use creator, but from second time onwards, what we can do? From the second time onwards, what we can do?
Apply.
Yeah, we can use the apply also, we can use. You got it right?
Yes, sir.
Okay, so now here that YAML file is namespace. And if we have the multiple resources, what we can do is like this is one resource and this is one resource. In the middle, you can keep that three hyphens we can keep. What this is telling in the same YAML file, we can keep the multiple also. But between those resources, what we need to keep? Three hyphens we need to keep. That means namespace is one kind of resource. And the second one here, it is creating pod. But in the real time, we don't deal with individual pods, right? What will create? So in the real time, we don't deal with the pods. What will create? We'll use either deployments or stateful sets or daemon sets only we'll use. But only just I'm giving an individual pod kind of instructions also. Then here, what is this API version also we'll discuss. Means for every kind of resource, while we communicate with the API server, we need to tell the exact API version also. Then only that API server or our Kubernetes will understand that. Okay, for each version of Kubernetes also, we have the different API versions. Sometimes in the newer version that V1 may be not there. Then you need to change that. Instead of V1, we may have that. We'll discuss. And this is creating a pod. And what is the name of the pod we given is my app pod. And if I don't specify namespace, what is going to happen? In my pod, if I don't specify namespace, what is going to happen? It is going to create in the default namespace itself. Okay, it is going to create in the default namespace itself is going to create. Okay, that is the reason it's recommended to queue. It's recommended to give. It's recommended to use the namespace also. If I don't give this, it's going to create in the default namespace. Okay. Then Like here we are going to give the labels, why we need the label specifications also we'll discuss. Then I'm giving the image and one name also for the container also. If I don't give the name also, no problem, but it's mandatory I need to give. It's mandatory I need to give. The image is required. Then that ports also we are going to provide to this. If I run this, it's going to create two resources. One is namespace. Second one is, it is going to create two resources. One is namespace. Second one is the pod is getting created. If I run the same command kubectl apply -f, that maybe my I kept is my manifest dot uh, YAML or YAML, then all that resources in that are getting created. Okay. So then here we have a namespace. First we have the API version, right? Which version of API we are going to use, that's we need to specify to the API server. And V1 is most of the core Kubernetes objects like namespace, pod, all these we are coming in the V1 edition. Okay, so we'll discuss all these also. Like a manifest file will tell dev. Okay, and my app is the pod name, which namespace we need to use. Labels are very important, and specifications also very important. We'll discuss that. Okay, so then here we have for the resource, what is the API version I'm trying to explain. Okay, for the pod, what is the API version? V1. For service also, most of the basic objects all we have in the V1 namespace. Then another one is, what is another API version we have? Apps/V1. Okay. You are using deployment, StatefulSets, DaemonSets, ReplicaSets. For that manifest files, YAML files, what we need to use the API version is not V1. We need to use app/V1 we need to use. Okay. And for the Ingress or for network policies, what is the API version? For Ingress and network policies, networking.k8s.io/v1. Okay. Maybe in the older versions, that these API versions also will change from the Kubernetes one version to another version also. It's maybe changes, and some older API versions are going to be depreciated also. The older API versions have been depreciated also is going to happen. Okay. And for store, so these all the API versions we need to remember. Okay. So we have V1, then we have apps.v1, and for Ingress and network policy, what is API version we have? Networking.k8s.io/v1 we have. Okay. Then for storage also we have storage.k8s. Okay. And depends upon the resources, we have these API versions we have. Okay. Or back. So these how to use that also while designing this, we can discuss. And here if you go this kubectl API resources, this command if you show, all that it is going to display. Okay, so that means depends upon that Kubernetes version. If you have any doubts on that, that's we can specify there. In the kubectl API version, we can specify that one. Okay. Previous APIs, what we discuss is 1.29, and these all for 1.30. 90% almost all are same, but for some resources, it's maybe changes. That's how we can get that is, what is the command? kubectl API resource. And here otherwise we can get that kubectl explain that resource also. Say suppose if you have the pod, then kubectl explain pods or explain deployments. In that also you are going to get that what API version we need to use. I hope you got it right. Any doubts on this? I'm audible to you?
Yes.
Okay. So then here we'll discuss this, like we don't deal with the parts, right? We'll use the deployments. And what is the API version we have? Not V1. For pod, we can use the V1, but here we are going to use app/V1. And what kind of resource that is? What kind of resource that is? It's a deployment because we don't want the pod. Then that name we have given is Tomcat-deployment. And why we are using that labels and specifications we'll discuss. Labels and selectors. Specifications we are giving replicas is 2. If you want maybe if I give 8, then what is going to happen? It's going to create 8 replicas is nothing but 8 parts are getting created. If I give here 8, 8 parts are getting created in that. Okay. So then for each pod and that labels also will play the vital role, and we have the selectors. Then in the template, we are going to give like specifications like which container image we need to use in the real time. What we are going to use is our own customized images, which we have created through Docker file, we are going to use. Okay. And to that deployment, it is going to create maybe how many number of replicas we have given, that many number of parts are getting created. But we are going to manage the services also we are going to use. Say that service and this deployment. Okay. So now here, what is the purpose of labels and that selector is, say in the pod, it's creating 10 pods. All these need to be linked to that deployment, and this deployment and that service also need to link because that service is going to recognize that parts and based on that selectors and labels. If I have the different labels, if I use in my deployment and if my service, say here, what is the label we use here? App:*Tomcat. And when I'm creating my service, if I don't use this selector, okay, then what is the problem I'm getting is that service and deployment is not linking. But now what is going to happen is that service is going to link to all the 10 parts, or maybe going forward, it may be scale up also 15 parts and some part deleted also. But we are getting the same pod labels, and this based on this selector is matching. That service is going to discover those parts belongs to this, parts belongs to this deployment. Part belongs to this deployment that is going to understand. Okay, so that's the reason when we are linking this deployment with the service. Okay, so what I'm doing here is I'm attaching labels to my deployment, and using that labels, I'm linking it to
Sir, you linked it with selector, no, sir?
with this, but we need to give at some point, we need to give the label, right?
Okay.
Okay, for the deployment, we are giving the label. With the service, how that is linking is, what is the name label we have given? That we are attaching here. Assume, I'll tell one example. You have your house number, right? That house number should be with your house. Okay. Maybe I want to send a card for your house number. I need to give in my card what I need to give. Your house number I need to write down in that postcard. Then only it will reach you. Hence, we are giving a label to our deployment, and we are attaching that to the service or parts also based on that selector. Okay, the 10 parts also need to belongs to that deployment only, right? That is also is going to happen here. So now this, whatever the template we are giving, right? In the template, whatever the details we have given, these all the same for all the 10 replicas, those are the same. Are you able to understand? Means here in the deployment, it is creating almost 8 replicas. Then all the 8 replicas also in my template, whatever the things I have given here also I'm attached labels all these. Okay, so that means all are attaching to that same pod it is attaching. That means all the pods also linking to the deployment and service also is linking to that deployment. What is the label we use here? It's a key value pair. What is the name of the app is? Tomcat. If I don't give here in my service, okay, if I give not your house number, if I give other house number, what it will happen? It goes to other house, right? That's the reason exact selector we need to link this. The label we attach it to the deployment, but we are using here the selector, and with the selector we are attaching that label and this selector. Both need to match. Okay, then even to the parts also, 8 parts or 20 parts, whatever it may be created, those are linked to that deployment itself. Then even service also is going to recognize those parts belongs to this deployment based on this selectors itself. Okay, so based on these selectors itself, it is going to understand. So whenever we are linking that deployment or stateful set, we need to make sure that service and these should have the matching labels and selectors. Matching labels and selectors. Okay, so kind is no doubt it's a deployment. Okay, so then we have a name of the deployment we have given, and the labels are nothing but key value pairs. Maybe for the grouping or selecting the resources, we are going to use them. Okay, and replicas will tell how many number of replicas of the parts need to run. Okay, then it's app Tomcat. These labels are specifying the parts also, and those parts also recognizing that deployment both belongs to the same parts. Okay, so then we need to give the parts also here also need to match with that. What we are going to do is now to the service also we are creating the type is service. If I don't specify any type of the service, what is going to happen? If I don't specify any service type, what is going to happen? By default, it is going to create the cluster IP. By default, it is going to create the cluster IP, and based on the selectors. So here this service routes the traffic to the parts with the app and Tomcat label. Okay, all should have the same one we need to manage. Okay. Any doubts on this? Any doubts? Then even we are going to attach the port numbers also. Here we are going to give protocol is TCP and port is 80. 80, this is externally, and ports 80, 8080 on the container. That means outside host port will give, right, like 80:8080 like this. This is example. Host wise, this is 80, but internally the Tomcat is going to listen 8080 for us. The target port is inside the container level, and that port, normal port is at the host level or node level we are going to give. Okay. And if I specify type is NodePort, means the service type is not cluster IP. It need to use NodePort, And for the NodePort also, we can give the port range. If we don't give the NodePort, it is going to automatically create. And what is that port range? What is the NodePort port range? 30,000 to
32,760.
32,767 it is going to use. Okay. Then here this all we can keep in the single manifest file by giving the 3 hyphens, and finally we need to run kubectl apply -f that YAML code. Okay. And once we create that, maybe we created the deployment. Okay. So what we can do is, say deployment is going to create, say here, kubectl get deployments. Okay. Then -f, that file we can use. Okay. Sorry, not -f, namespace. That namespace you need to give. And get pods also we can use. Get SVC is nothing but that service. But if you use that namespace, definitely we need to give the namespace. Otherwise, it is going to use. Otherwise, it's going to give the default namespace resources itself. The default namespace resources itself we are going to use. Okay. But here what is that labels are? Like we can attach that key value pairs now, like that app is the key. That value we have given is Tomcat. Okay. And we can have the multiple labels also we can attach. Okay. But we can filter or select based on that selectors. Okay. So now we can select or match that resources based on that labels. Then it is going to pair that. Okay, so now here mostly we are going to use equality base is not the best practice. Better to use the set base. In the equality, exact matching need to be done. But we can use set base also, have more regular expressions, all that we can use. Okay, so selectors we can use either equality base we can use, or set base also we can use. Okay, so now the services to the pods and services to the deployment, all that also, and replica sets and deployments, all are matching based on those. And even based on that labels also, we can filter also. So based on that, we can filter also. So even in the Kubernetes, in the AWS, we are using tags itself for this. We are going to use the tags itself for this use case. Okay. And for the different environments also, we are going to keep different environments, and even in the blue-green deployment also, blue kind of labels and green kind of labels, all those also, we are going to keep it. Okay. Yeah. Any doubts on this? That service level, we want to use the label or selector? Because at the pod level, we given the labels, and to the service level, I said one address, right? In the postcard, if I give the wrong, like a house number, what happens? That post never reaches. In the same way, in my selector also, if I give the wrong thing, what is going to happen? It won't forward any traffic. Okay. And even the deployment also is not going to manage. Okay. Yeah. Any doubts on this? But always we need to make sure that deployment pod and services for one set of these should have the same labels and labels and selectors. Okay. Then next one is stateful set. So stateful set also, the kind of resource is stateful set and API version is app/v1. It's not v1, app/v1. And even we are going to specify, almost it looks like a deployment itself. But what is the prerequisite for this is, we need to create a headless service also. So almost headless service also looks like same, but what is the difference? For the headless service, what is the difference? Headless service will have, like cluster IP is none, we need to keep. If you keep that cluster IP is none, then that is going to become the headless service. Then, like for daemon set, what is the difference between deployment and daemon set is? In the deployment, we need to specify the number of replicas, but in the daemon set, each node, one pod would be running. Mostly for the monitoring kind of agents, CSI, CNI kind of agents, or storage accounts, or maybe like log collection agents. For that, we are going to use like a daemon set. Node exporter, it may collect all the node information, like monitoring information, and it is going to send to maybe like Prometheus kind of servers, or maybe we may have like a ELK stack also, log stash will run as the daemon set. That means it need to run on each and every agent. It need to run on each and every agent. Okay. So then here daemon set on each pod it is going to run. Maybe Prometheus node exporter or log stash or Fluentity. These are in the ELK stack. We have security agents on each and every node it need to run. Okay. Mostly when we use the CNI kind of thing like Calico, Flannel, View, all these also need to run on each and every node. Okay. Storage drivers also maybe need to run on each and every drivers. These kind of things we are going to run as daemon set. Mostly your application microservices we don't run as the daemon set. Our application microservices mostly front end related. So front end microservices we are going to keep in deployment because those are stateless applications, and the backend microservices mostly will use the backend microservices will keep as the stateful set we are going to specify. And if you have any Redis or maybe Kafka, or we may have MySQL, Postgre, okay, say like even Kibana. So these kind of things, can you tell me which resource is the best one? Deployment or stateful set or the daemon set? So for Redis or MySQL kind of SQL, NoSQL kind of, for all these, it's always recommended to go with stateful set itself. Okay. So for those resources also, we need to go for stateful sets. Okay. So maybe for stateful apps like backend apps and stable identity, persistent storage we want. Okay. Then we are going to use stateful sets. And if you go to the services, mostly by default, we have 4 types, but additionally by using headless service also we can tell. And those 4 types of services are ClusterIP, NodePort, LoadBalancer, and external name we have. Okay. And by default, if I don't specify anything, it's going to become that service is like a cluster IP. And here the selectors will play the vital role. with which set of resource it need to link. It's maybe for deployment or pods, or maybe with the daemon set or with the stateful sets. But in the stateful sets, I don't create normal cluster IP. I'll create a headless service. That is the prerequisite for the stateful set. Okay. If I don't specify this statement also, there is no problem, because if I don't specify that type is cluster IP also, it is going to create a
Cluster IP.
cluster IP. And what is the difference between port and target port? Port is for external and the target port is inside the container. The target port is inside the container. Okay. So a cluster IP will expose only within the cluster itself we can access. Okay. Then NodePort. So we need to specify definitely NodePort also, like a type is NodePort. We need to specify in the specification. And say here that NodePort, what is the NodePort we given there? 30,000. 36. If I don't specify that, what is going to happen? If I don't specify that, what is going to happen? Any of the port range would be assigned. Any of the port range is going to be assigned. Okay. Yeah. Any doubts on this? Then how we can access this is that node will have an IP address, right? Any of the node IP colon that port range we need to give. From this internally we are going to access, or outside also we are going to access. Internally we are going to access, or outside also we are going to access. From outside itself we can access. Okay. Then load balancer, we can use any of the cloud-based load balancer. Definitely we need a cloud controller also. And using the AWS load balancer or AWS application gateway, sorry, AWS application load balancer, we are going to expose. Okay. So this is going to create one load balancer also in the cloud. You can use AWS ELB or Azure load balancer or Azure application gateway, GCP load balancer also. But what is the major problem with the load balancer is for each service exposing one load balancer is expensive kind of thing. Okay. And we have an external DNS name. To that I want to redirect. Say outside I have one domain name. Say this is api.example.com. Then I want to link that to my service. Okay. If the outside if I use api.example.com, it is just redirecting to my service, but in the AWS environment, we are going to use Route 53 for this purpose. We are going to use the Route 53 for this purpose. We are going to create. Okay. And coming to the headless service, say for the stateful set headless service, we are going to create. And in the specification, what we need to give is, by seeing that line, we should able to tell it's an headless service. Okay. So what is that keyword is? Cluster IP should be none. And if I specify that headless service, okay, so that by default the service will do the load balancing, and based on the IP address that resolution is going to happen. But load balance doesn't work because it need to go to the same pod, and instead of IP address is going to resolve based on DNS name. Okay. So here we have the cluster IP, NodePort, but load balancing doesn't work with external name and headless service. Okay, so then we have the three types of probes, right? Probes are maybe the health check kind of things to validate, maybe at the liveness probe level, it's going to be pod is running or not. Okay, and if I go for readiness probe, the service always need to redirect to the healthy pod. And if I go for the startup probe, like a startup probe will suppress both liveness probe and readiness probe at the starting of the application. Okay, at the starting of the application, it's going to be reduced. Then here we have like this is my pod or maybe deployment we may have. Then here I'm going to configure that liveness probe. It is always checking that manager slash HTML. That means our application path you need to give in that port number. And if there is any failure happens, what it is going to do? If that application is not reachable, then what it is going to do? It's going to restart the pod automatically because that application is not working, right? Your application path you need to give there. Okay, so it's keep on probing. Then if that no response is coming, okay, for every 10 seconds again it is going to send. And if the three times it's got the failure response, that assume that pod is not working, then it's automatically it's going to restart that pod. Okay, and if I use the readiness probe and if my response is not coming, what this will do is in the service discovery of the load balancing, that pod is going to be removed. If I use that, then always the user is going to be redirected to the user is going to be redirected to the healthy pod itself. That user is going to be redirected always to the healthy pod. Okay. Then if I enable the startup probe, okay, so this is going to suppress that liveness probe and readiness probe doesn't work when the startup is going to happen for the application. Okay, so liveness probe will check if the app is ready. If it is fails, it will restart that pod or container. Readiness probe, the pod is removed from the service endpoints. And startup probe, like use the time for starting up and disables liveness and readiness probe till that startup is going to happen for that pod. Okay. So that means here this is giving almost like for every 30 seconds and 5 times it is going to give the threshold. For each 10 seconds, like failure thresholds are not 3 we are doing. So how many thresholds we given? Almost 30 thresholds. And each time it's going to check 10 times. Then that within that 5 minutes it need to start. That manager slash HTML is our application path. Okay. So then here we have I want to schedule by default schedule a decision on which the nodes need to run, but we can also keep the controller by keeping name selectors, node affinity rules also. We'll discuss. So first we are going to attach labels to my pod. Okay. So that sorry, I'm attaching labels this time not to the pods, to the nodes we are attaching. Okay. So that means here to the node also we can attach and like by choosing that node what is going to happen is 1 second. Sorry, not name selector, it's node selector. Yeah. So now with the node selector, what is going to happen is, like we want to assign the parts to the nodes. Then with the node selector, what I'm doing is, I'm attaching node to the pod. Okay, I'm attaching a node. What is that example is? So here kubectl get nodes -- show labels. But I can label also. Kubectl labels nodes and our node name disk type equal to SSD. That means if I have 20 nodes, say assume only 3 nodes I have disk type SSD. For the 3 nodes, I'm going to give the disk type is SSD. Okay. Then that node name, if I use that like a node type equal to SSD. So what is the keyword I'm using? Node selector I'm using. Then disk type SSD, out of 20 nodes, how many nodes I have that label? Maybe only 3 nodes itself we have. Then only on the 3 nodes itself it is going to schedule the parts. But instead of this, it's always recommended to go for, okay, say node affinity rules. In the node affinity rules, what is the advantage is, node selector is simple, but exact matching, equality kind of matching need to happen. But if we have more options are available, more regular expression kind of things we can use with the node affinity rules. Okay, in the node affinity rules, I'm keeping the values in. Say here I use a regular expression in, and the zone is maybe in the Antarctica East one or Antarctica West one. In any of that value it reaches, I'm going to schedule. But these kind of like regular expression patterns are not supported in, is not supported in node selector. Where it is going to where it is going to use, like in the node selector, exact matching we need to give. But in the node affinity rules, what we can do, we can give the operators like in, not in, like this. Here we can give the multiple regular expression kind of patterns we can use. Okay, and here we have one more thing very important is, in the node affinity, we can specify required during scheduling, okay, ignore during execution. What is this meaning of required and preferred is, in the required, exact matching need to be done. If I don't specify preferred, and if that is not available, it's not going to schedule. I said one example, right? If I give only required balcony seats, only balcony is available, then only I'll take it. If not available, then I'm not going to watch the movie. But if I use the preferred, when I will go to preferred, if that required is not available. Okay, so now here what is that required like zones I'm expecting? What is the required zones I'm expecting? Antarctica East and Antarctica West. If that is not available, and if I don't use preferred, what is going to happen is it won't schedule. But if I use the preferred with another label, maybe say suppose I have maybe I have Australia I have. If I use that one, what is going to happen is if not available Antarctica East one, Antarctica West one, then it may go to another value. That's maybe I'm giving Australia to my nodes. Okay, so that is the difference between required and preferred. So that's not possible with the node selector. Exact matching if you want to give, then we are attaching labels to the nodes, and in the pod we are keeping a node selector, and based on that is going to match. But the best practice is always use the node affinity rules. For the pods, again, to the nodes, we are attaching the labels. And to the pods, we are specifying node affinity rules, which are matching to that it is going to schedule. And in the weight, what we can give is the preference order also we can give. The preference order also we can give to that. Okay, so now here 1 and 50, we are going to give the weightage also. Based on that is going to load balance. Okay, and another method we have is like here operators also we have, and pod affinity set to the pod we are attaching the labels, and in the specify that pod affinity. If the pod affinity that already one pod is there, that pod will have the label, and for the second pod I'm going to specify the pod affinity rules, and if that matching labels are there already in that node, I want to schedule my another pod also. That means assume here we have nodes and pod we have. So for pod A, I'm going to give the labels. Then pod B, okay. So pod B will have pod affinity rules. In the pod affinity rules, what is going to happen is if the pod A is matching labels we have, then and on that node itself, pod B also runs. If no matching labels are there, that means that pod A is not running, then we are not running pod B also. Okay, so like this here we are going to schedule pod affinity rules. In which use case we are going to use is like if pod A is running on that node itself, I want to run pod B also. If I want opposite, if pod A is running on node A, I don't want to run it, means I need to specify for pod B anti-affinity rules we need to specify. If I specify pod anti-affinity rules, if pod A is running, then it's not going to run the pod B. Okay, so like this, we are going to specify pod anti-affinity, and say here we need to specify pod anti-affinity. Okay, if the pod labels having this backend, then this pod doesn't run. Okay, so like this here we can use the pod affinity and anti-affinity rules. And in the previous scenario, we attached like labels to nodes we have attached. Then node affinity rules we specified to pods, or we can attach labels to nodes. Then we have node selector we use, and directly equality base it's going to attach to that pods. Okay, but another method what we have is to the pods we have given the labels also, and based on the pod affinity and anti-affinity, other pods also are going to manage that rules. Okay, then one more, what is the another method we have is, now we are attaching taints to nodes, then tolerations to the pods. If I attach taint to the nodes, okay, for all those nodes repel. And a scheduler, even if you want to schedule on that specific node, it won't accept. Only if any pod comes with the toleration, that is allowed. Okay, that's the reason taint we are attaching to our node. Okay, so what is the command is kubectl taint that node name, then node schedule is we are going to use. Then if the pod comes with this kind of toleration, okay, that is only allowed on that node. Remaining normal, all the pods are not allowed. By default, those all will repel. By default, those all will repel to that. Okay, so that is the purpose we have taint and tolerations. The label selectors, we are connecting that to the node to pod also we can use node affinity on that specific nodes if we want to schedule pod affinity. If already one pod is running on that itself, we want to schedule one more pod. Anti affinity, if one already pod is running, I don't want to schedule the pod. And toleration only allows that pods on the tainted nodes itself. Have some reserved nodes on that itself, I want to run my applications, then we need to use the taint and tolerations. Okay, so till this we'll discuss. In the next session, even some more resources also like HPA, cluster autoscaler, pod disruption budgets, CRDs, remaining resources manifest files we'll discuss. Okay.